So here we're doing, this is the short answer section, and once again the tests were different, but the logic is all the same. N is equal to 3, so that means we're talking about a 3, L equals 2, so a 3D element. So if we look at the 3D sublevel, there'd be 5 orbitals. By convention, we said we're going to go -2, -1, 0, 1, and 2. And so that means we're talking about this orbital. We said that by convention, the first electron in, we're going to call a positive 1/2 spin. So you go single, single, single. So you're really looking for a 3D electron. All right, so if we're looking, or 3D3, so that element is vanadium. And it'd be, so you'd have 1s with 2 electrons in it. 2s, let's make that an s a little better. 2s with 2 electrons in it. 2p would have 3 orbitals. 6 electrons. 2, 3, 4, 5, 6. Then 3s, 1 orbital, 2 electrons. 3p, 3 orbitals. Oops, I'm not doing that correctly. What did I just do wrong there? I should have gone single, 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 pair, pair, pair. Then 4s. Then 3d. So 1, 2, 3. 3d3. All right, and we know that once again because -2, -1, 0, 1, and 2. Positive, positive, positive. And if you kept going, it'd be positive, positive, and then negative, 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 and so on. What I haven't learned how to do yet is to turn this on and off so I can toggle through my pages in Word. So we'll do this. We'll exit and start again. Now question 2, the highest level quantum numbers in iron. Okay, iron is a 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. So I'm going to focus on the highest energy electrons. I'm going to draw the electrons in the d orbital here. 1, 2, 3, 4, 5, 6. By convention, we said -2, -1, 0, 1, 2. And the second electron in would be a -1/2 spin. So a positive, 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 and then negative. Then negative again, and so on until you get to 10. So for this electron in, that would be this electron right here. N equals 3. Since it's a d sublevel, L equals 2. Since it's in the -2 orbital, M equals -2, and S would be the second electron in, -1/2. Question 3, I'm going to go ahead and do question 3, then we'll do question 4 above number 4, so I don't have to mess with my pen again. A single p orbital would look like this. If I had asked you for a single d orbital, you could have drawn this. There would be 4 of the 5, these 5 up here, 4 of them look like this. And 1 of them looks like the dumbbell and the donut, like that. So those are Ds. Okay, now all the orbitals you expect to find in neon. Neon's a 1s2, 2s2, 2p6. So you'd have one orbital, and 3 orbitals. So what I was expecting you to draw was a sphere and a bigger sphere, because 2s would be a bigger sphere than a 1s. And then these 3p orbitals would look like this. You'd have one on the x-axis, one, I got left a little slanted, we'll call that the z-axis, because it kind of goes back into the page, or into the computer screen in this case. So that would be x, that'd be z, and the y would be vertical. I'm not very good at vertical on this thing, it looks like. All right, anyway, those are your 5 orbitals. 1, 2s, and this is a 2p1, 2px, 2pz, and 2py. All right, that was 3 and 4. And then number 5, let's get our ink open again. Okay, so we've got an orbital diagram for selenium. And selenium has 34 electrons. So we'll be looking at a 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p4. So 2, 4, 10, 12, 18, 20, 30, 34. Did I say 36? It has 34 electrons. That's selenium, it's 34. So 34 electrons. All right, so I'm going to draw the orbital diagram. So I'm going to go ahead now and put the orbitals in. All the s's have 1 orbitals, p's have 3. D's have 5. P's have 3. Now we're going to put the electrons in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, remember Hund's rule, and 34. Okay, that's your orbital diagram with all the circles. The orbital diagram does not necessarily include the superscripts. You can put them on if you want. So now we want to know how many have an m value of 0. Well, when L equals 0, m has to equal 0. So this would be an m value of 0. And how can I show you this? So this is 0. Those are going to be my m values. And that's 0. -1, 0, 1. So it's this one. 0. So how many electrons so far have an m value of 0? 2, 4, 6. 2 there make 8. There's our 0 value for m. That's 10. M equals 0 there is 12. -2, -1, 0, 1, 2. So these two have an m value of 0 right here. But in this sublevel, that's -1, that's 0, and 1. There's only one electron that has an m value of 0. So the number of electrons that have an m value of 0 would be 2, 4, 6, 8, 10, 12, 14, 15. All right, that's the end of that one. So hope that helped on the short answer section.